Welcome back to this course on ACL injury rehabilitation, the week 4 intermediate phase. Lecture 19, Progressive Strength and Power Development in ACL injured athlete, Rebuilding the Lost Strength and Power. I am Dr. Jaren Shaji from the Department of Sports Medicine, AFMC Pune. In this lecture, we will be elaborating on the importance of progressive strength and power development in ACL injured athlete during the intermediate phase of the rehabilitation process. The learning objectives of this lecture are: what is strength deficit post ACLR? Understanding evidence-based progression models, exploring velocity-based training approach, looking into neuromuscular adaptations and monitoring, return to play strength benchmarks. Strength deficits post ACLR. Various muscles get detrained or weakened due to something known as arthrogenic muscle inhibition post surgery. Especially this happens for the quadriceps muscle. Also the hamstring and the gluteus muscles are weakened due to inactivity. Coming to quadriceps weakness, profound weakness of the quadriceps is common after ACLR and persists even after 6 to 9 months if not addressed properly. This deficit impairs knee extension, running, jumping, and safe deceleration mechanics. Hamstring weakness. Strength imbalance in the hamstrings are frequent, which is exacerbated when a hamstring graft is used. Adequate hamstring strength is essential to control the anterior tibial movement and provides dynamic knee stability. Gluteus weakness. The weakness of gluteus maximus and medius muscles alters hip and knee biomechanics, leading to compensatory patterns and increased risk of secondary ACL injury. All deficits must be therefore addressed for a comprehensive neuromechanical recovery. Coming to evidence-based progression models. Here we usually progress strength training from starting from isometric exercises, progressing to isotonic exercises, and later on plyometric exercises for especially sports persons. The isometric phase. Isometric exercises are exercises in which we hold the muscle tight without any movement. These are used in early protection state, such as static quadriceps exercises or setting, glute bridges, static hamstring holds to activate and recruit muscle fibers. This is initiated as soon as the pain and swelling allows. Coming to isotonic or concentric eccentric exercises. Concentric exercises are exercises in which muscle contracts, causing reducing in the muscle length, and eccentric exercises are exercises in which paradoxically, although the muscle is contracting, the muscle is lengthening against a resistance. Isotonic exercises are nothing but using the same weight to conduct either concentric or eccentric movements. They are progressed to loaded knee extension or flexion, adding squats, step-ups, or Romanian deadlifts as tolerated. The emphasis should be on movement control and performing with limb symmetry. Add the resistance as the technique improves. Coming to plyometric progression. Plyometric exercises are specialized explosive exercises using the stretch shortening cycle. They are typically box jumps or drop jumps. These are introduced in the late intermediate and advanced phases of rehabilitation based on clinical criteria with no pain, good squat and landing mechanics, adequate closed chain strength. A structured four-stage model of plyometric progression is recommended, starting with low intensity bilateral plyos first and progressing to high velocity single leg and multi-planar tasks as the function of the knee and the lower limb kinetic chain improves. The image shows evidence-based progression model from isometric progressing to isotonic and plyometric stages. Coming to velocity-based training approach. This is a specialized training in which movement or contraction velocity guides the load intensity and progression. The contraction velocity is measured using a linear position transducer or even accelerometers and inertial moment sensors. The velocity zones target power versus maximum strength with a more individualized adaptation than the classic repetition max based models. The application in early phase focuses on controlled velocities for basic strength development, then progressing to higher velocities for power development as the form and knee tolerance allows. This real-time feedback motivates effort and reduces unnecessary fatigue while quantifying the progress in athletes. As mentioned, for this specialized training, we require particular accelerometer based sensors. Coming to neuromuscular adaptations during rehabilitation. These adaptations emphasize on restoration or motor movement patterns, proprioception and balance, as well as dynamic control in especially landing mechanics. There may be persistent deficits in sensory motor control which often exist up to 1 year of post-operative period regardless of the rehabilitation process or the treatment. Hence, these neuromuscular adaptations have to be continuously monitored in order to return the athlete or the individual back to his activities and sports. This can be done using surface electromyography electrodes or EMG, limb symmetry index, real-time biofeedback using video analysis, or serial functional testing using field tests like Y-balance test, hope test, and landing analysis. For patient-specific progression and to identify maladaptive compensatory patterns, these techniques are very useful. Now coming to return to play strength benchmarks. Some of these benchmarks are quadriceps and hamstring strength with limb symmetry index, which is the ratio of strength of the injured divided by the uninjured side. This should be more than 90% for the injured side using isokinetic dynamometer testing as a gold standard. Functional tests such as hope tests also can be used to find out the asymmetry threshold. This has to be less than 10%, which is recommended. These hope tests are of single hope, triple hope, or crossover hope tests. Coming to close kinetic chain strength, this has to be more than 1.5 times the body weight and is often used as a criteria to progress to high demand plyometrics and field drills. Psychological readiness. This can be evaluated using the anterior cruciate ligament return to sport after injury scale, which is a 12-item questionnaire used to measure the athlete's psychological readiness to return to sport after ACL injury and reconstructive surgery. It assesses three key aspects such as emotional well-being, confidence in physical performance, and risk appraisal on a scale of 0 to 100. A higher score indicates higher psychological readiness and is associated with higher likelihood of successfully returning to sport. This is an important tool which can be used for decision making in return to sport. The table shows various parameters used as criteria for return to sport. These are my references. Thank you very much and Jai Hind.